All MIDI note-on and note-off messages include several bytes of data. Naturally, the message type is identified and the particular note is specified based on the MIDI note numbering standard. Additionally, each MIDI note message describes how that note was played, that is, how hard the note was hit. How hard a note is played is basically how fast the player pushes that key down into the MIDI sensor below it. Faster speed equals harder playing, and so the term for this aspect of MIDI note data is velocity. Due to the limited capabilities at the time MIDI was introduced, MIDI message data is limited to 7 bits, which provides for 128 different values. So, with the numbering starting at 0, same as a note off, MIDI velocities can range from 1 to 127, with 1 being the softest played notes and 127 the hardest. For most virtual musical instruments, this is interpreted as volume from softest to loudest, and for virtual instruments that mimic acoustic instruments, other aspects of the sound may also be programmed to respond to MIDI velocity data. For example, with virtual drums, higher velocities will usually result in not only louder hits, but also sharper transients and brighter tone, just as with real instruments. But it's important to remember that the MIDI data has nothing to do with the sound. It's just a record of how the performer played. The virtual instrument is free to interpret that data to provide any kind of change in the sounds that the sound designer might want. Natural response, as described, or some other response, maybe even for special effects. MIDI velocity data can always be edited in a finished recording, making it possible to change the dynamics of the performance after the fact, a powerful creative tool if used appropriately.